When we talk about logical consequence and logical equivalence, what we mean is we're using particular arrows that allow us to show that one thing implies another, and perhaps vice versa. So if we're looking at consequence, what we mean is that if A is true, then this implies B is true, for example, okay? So we would say here that A implies B. So this means A implies B, okay? And if we had the arrow pointing the other way, notice how it is a particular way, how I'm drawing the arrow here. We are saying that B implies A. Okay? So let's say we've got an example where we've got two statements, A and B. Statement A says that P is a prime number greater than 2. Okay, this is my first statement. The second statement says P is an odd number. Okay? So we've got these two statements. Now, which way should my arrow point? Okay? Or can I draw an arrow at all between these two? So let's consider this. If we start with the left-hand side, P is a prime number greater than 2, then P has to be an odd number because there is only one prime number that is even, and that is 2. So if the prime number P is greater than 2, we definitely know that it has to be odd. So the arrow must point from left to right, okay? So it is definitely going that way. Now, we do need to check whether it works the other way as well, okay? If P is an odd number, does that mean, okay, so completely ignore that for the moment, just focus your attention on this. P is an odd number. Does that mean that P is a prime number greater than 2? So just because P is an odd number, we've got the numbers 1, 3, 5, 7, 9, 11, and so on. Does that mean that P is a prime number greater than 2? Well, in that list, I've mentioned the number 1. 1 is definitely not a prime number, and it's definitely not greater than 2. So we cannot have the arrow pointing from this statement to this one. This statement does not imply that one, okay? So the arrow only points from left to right in this case. Now, if it had pointed from right to left as well, we would have said then that this statement was a logical equivalence. Okay, so we write the arrow pointing both ways. Okay, this means that A implies B and B implies A. Sometimes we write it as and we say A if and only if B. Okay, and as such, some people have taken, some mathematicians use the notation A if and only if B. Okay, so an I and two F's. So what this means is that we need to check that the logical statement works from left to right and from right to left. Okay, so in this case, there was no logical equivalence, okay? However, an example of this would be n squared is odd. That's my first statement, that's statement A. And my second statement is n is odd. Okay. So if we think about just looking at the left-hand statement, n squared is odd, then given that n is an integer, okay, then n squared, we'd be looking at 1, 9, we'd be looking at 25, so the odd square numbers, and subsequently, for each of those, n is 1, 3, 5, 7, 9. So because n squared is odd, that means that n is odd. Okay? So the arrow definitely points that way. Now if we consider the converse of that, looking at right to left, if we just think about, given the information that n is odd, when I square n, do I always get an odd number? So 1 squared is 1, 3 squared is 9, 5 squared is 25, 7 squared is 49, okay? So any odd number, when it is squared, any odd integer, when it is squared, we get an odd number. And so the arrow also points from right to left. And so we can draw in that it is an equivalence. Okay, an if and only if statement. So if you are faced with a pair of statements and you need to determine which way the arrow points, look at the left-hand statement first and then ask yourself, does that mean, if that's true, that the right-hand statement is true? If so, it points from left to right. Then think about the right-hand statement. Does that then imply, if it is true, that the left-hand statement is correct? If so, the arrow can point from right to left. Okay? And if it works both ways, it is an equivalence symbol. Okay? So that is how we work with these logical consequence and equivalence. And we're going to go through a few examples in the next video.